So we know how to balance chemical equations now. Let's use those balanced chemical equations to talk about different types of chemical reactions. Here are our objective and essential question. Again, as always, I encourage you all, whenever you see this handwriting icon in the top right corner of your screen, to pause the video as you see fit to record what is on the slide. So our objective today is to be able to identify and describe the four main types of chemical reactions. And our essential question that you all should try to answer in the summary at the end of your notes today is what happens to the reactants and the products in the four main types of chemical reactions. So our first type of reaction that we're going to discuss today is the synthesis reaction. So what happens in a synthesis reaction is two different atoms or molecules are added together to form a combined or different molecule or compound. So our chemical formula that we would use for a synthesis reaction, these are not real elements on the periodic table. Well, I suppose B is for boron, but we do not have an element that is simply a capital A on the periodic table. So just note that these are basically our variables, A, B. When we get into different types of chemical reactions, we'll go over C and D as well. So these are some essentially variables. They're representing symbols to describe what is happening. So we have an element or a compound combining with another element or a compound to form a combined element, or excuse me, a combined compound. They will not form a element anymore. So an example of this would be synthesis of sodium chloride, which is table salt, right? We have the individual element of sodium, we have the individual element of chlorine, and together they form table salt or sodium chloride. If this is confusing for you, I also always like to think of it in terms of drawings. So say maybe we had a cloud plus a sun together, they would make a partly cloudy day. If you've ever seen this symbol on your weather app or the weather channel, this is a good example here. Again, so in this case, we have our A, which is our cloud. We have our B, which is our sun. And this is our AB compound. Our next type of chemical reaction we will talk about is the decomposition reaction. So the decomposition reaction, I like to describe it as essentially the reverse of a synthesis reaction. It's when a molecule or a compound breaks down into two or more simpler substances. So in this case, if we were using our partly cloudy example again, we have our partly cloudy day outside, and maybe the clouds started to clear up. They started to detach themselves from the sun in the sky, and we would again form our two separate compounds here. So this is a decomposition reaction. We have our AB complex, and then it divides itself into A and B again. A good example of a decomposition reaction is the decomposition of carbon dioxide, right? We have carbon and we have oxygen forming carbon dioxide here in the reactant side of the chemical equation, and it breaks down into individual pure carbon and pure oxygen. Our single replacement reaction is a little bit different from our synthesis and our decomposition reaction, but our single replacement reaction is when one element replaces another in a compound. It's kind of just as it sounds here. So in this case, if we're using our sun and our cloud example, we have our partly cloudy again. And maybe there's a chance of thunder and lightning, or maybe there's a chance of rain. I'll draw some rain here. So in a single replacement reaction, what happens is this rain is going to take the place of the sun and the clouds. So now we have our rainy day, and we have our sun is gone. Okay, so in this case, we're adding another variable here. So we've got our AB, and we're adding C, which is our rain. So now we start to form that C is replacing B here, and we form a complex of AC and B on its own. So an example of this is carbon-3 chloride to aluminum chloride. We start off with the compound carbon-3 chloride, and aluminum replaces copper here as the metal bonded to chlorine. So now we end up with aluminum and chlorine and copper out on its own. Finally, our last type of reaction is very similar to single replacement. This time we are making a double switch. So we call this a double replacement reaction. And this is when the cations and anions of two compounds switch places. So in this case, you see our variables, we're adding one more, we're adding D. So A is switching places with C in this example, and B is switching places with A is switching places with C. B and D are not switching places. Otherwise, we just go back to our original form of A, B, and C, D. So we were to look at this with our weather example again. Say we had our partly sunny day. And maybe we added, let's see, some rain. Maybe we had a day where it was rain and some lightning. So we got a pretty big thunderstorm here. And I'll do my lightning in purple. So you all can see, hopefully, that is lightning. Right, that's a pretty poor. There's the lightning. Okay. So if we were to switch these around, right, we've got A, B, and C, D. Now we're going to switch places. So say we then end up with a very cloudy day and some lightning here. Okay, so that's our first compound. So we are switching and we are saying, oops. So we have switched places here, and now remember A was our cloud. So we'll say that is AD. And now we have a crazy day, if you have ever witnessed this, where the sun is out, but it's also raining. And this is our BC compound. So they've switched places there. And a good example of a double replacement reaction that happens fairly often is silver 1 nitrate and to becoming silver 1 chloride. So silver is bonded to nitrate and it is reacted with sodium chloride. And what happens is the chlorine and the nitrate switch. So then we end up with silver 1 chloride and sodium nitrate. So hopefully this gives you a good introduction to the 4 main types of chemical reactions, and I look forward to discussing this in class with you all later.